Hi, Kirill. Everyone, this is Kirill Kuznetcov. He's the lead blockchain engineer at 1inch. He's going to be taking a workshop today on, is it limit order protocol? The limit order protocol on the 1inch text DeFi aggregator platform. I'll let you take it away, Kirill. Have fun with it. Everyone, feel free to ask questions in the chat. I'll ask them to Kirill once the workshop is over. Thank you. Have fun with it.
Thank you. I'll start sharing. Okay, first of all, I want to start with a few words about the 1inch network. What is it, when it was built, and etc. etc. 1inch network was built at 2019 at New York Hackathon. It was a largest Ethereum hackathon, and Sergey Kuntz and Anton Bukov built the first product of the 1inch network. It's called 1inch aggregation protocol. This protocol search deals across multiple dexes, and the rates are better than any individual exchange. And this aggregation protocol incorporates Pathfinder algorithm that allows to find the best path among different decentralized exchanges, private market makers, limit orders, and any swap-based protocols on Ethereum, Binance Smart Chain, Polygon Network, and also Optimism Layer 2 solution. We have about 70 plus liquidity sources on Ethereum, 30 plus on Binance Smart Chain, and 20 plus on Polygon Network. And currently, we are one of the latest DEX aggregators on the market that offer the best rates among the centralized world. And now our protocol is a limit order protocol. Limit order allows user to create, to build and sign the order off chain. And if someone wants to execute this order by given price on chain, this user can just take this order from backend or mesh network and execute it on chain. And interesting thing that the user who creates the order, he don't need to pay minor fees for this order. This order for the maker is totally free, totally free. And the user who is a taker, who want to fill this order, this user should pay minor fee for order execution. Yes, it was the quick introduction, and let's see how limit order contracts works and what features we can use. 1inch limit order protocol has three main advantages. The first one, it's conditional execution. You can check during the execution, is your order valid or not, and you can build any condition that you want. Maybe it's a Chainlink Oracle price, maybe it's a block number, maybe it's a timestamp, or any other on-chain data that you can fetch through view functions, or maybe pure function. The second advantage of 1inch limit order protocol is arbitrary price discovery. You can use any formula that you want for exchange. You can forget about proportional price discovery. You can build something like maybe based on the volume, price based on the volume, or maybe price based on the Chainlink Oracle. You can choose any source of price derivation that you want. You can also connect limit order protocol to another DEX, for example, to Curve, and you can build an adapter for the Curve and fetch the price using get dy function on the curve exchange. And you can just set the limit order, and the user who wants to execute this order will trigger the exchange function on the curve exchange, and uh, you will get the amount that you want that you set. And another interesting feature of 1-inch limit order protocol, it's a custom callback during the execution. You can perform any action after the before the transfer from function is called, and it can be, for example, a flash loan payout, or maybe some collateral debt or returning debt. You can any action. You can do any action that you want using this custom callback. And let's dive deeper into the order structure and function that you want to take a look. The order structure consists of the next fields. The first field is salt. It's a random generated number that protects you from double spending. Also, it's maker and taker asset. This is the addresses of the tokens. Maker asset, it's the token that you want to um, the token that you want to send to the taker, and taker asset, this is the token that you want to receive after the order execution. Maker asset data and taker asset data, this is the ABI encoded bytes that starts from the transfer from function selector. For the maker asset data, the first parameter, it's your address as a maker. The second parameter you can set to 0 address if you want to use your order as a public order, and if you want to use private orders, you can just set another user address here. And also maker and taker amount that you want to send and receive. Now to bytes, it's get maker amount and get taker amount. This is the ABI encoded function that allows you to calculate um, for the first parameter, it's calculate swap maker amount given swap taker amount, and the second in other turn. Like you will contract will pass maker amount to the parameters as the last argument, and in the return contract will get swap taker amount. And you can encode any function that can calculate your price for the execution. Now a parameter property, it's a predicate. This is the function that returns a Boolean expression. Like you can check is your order expired or not, or any condition that can be checked on chain during the transaction mining process. And permit, this is the function for tokens which supports permit. And the last bytes, it's an interaction. This is the ABI encoded function for callback that you can call on any contract that will execute 1-inch limit order contract. And let's see how to execute the order. You need to call the fill order function and place your order as the first parameter. The second parameter, it's a signature of your order, of the maker order. This is the signature using site type data v4 structure, and making amount, this is the amount of maker asset that you want to buy, and taking amount, this is the amount of taker asset that you want to sell. And one of those parameters should be 0. For example, if you know how much you want to sell, then you need to place taking amount. And if you know which amount you want to buy, then you need to set making amount. And the last parameter, it's a threshold amount, something like minimal return. Uh, it also uses, usually it used for uh, dynamic price generation without the proportion formula. Let's look at the predicate condition. For example, for on our user interface, we use two predicates to build the limit order. The first one, it's nonce equals and timestamp below. Non-sequels allows us to cancel the order, just increment the nonce, and you will no longer can execute this order. And timestamp below allows us to build the order that will expire after this timestamp. And to combine two different predicates, you need just um, um, make an ABI encode on end function and place targets and targets array and data bytes array to this function. And you just encode the nonce equal with the parameters at the zero index of these parameters. And the second, you just encode timestamp below with your expiration timestamp and append this encoded ABI and target address of the contract where this function exists to the end function. And just place this encoded end function to the predicate property in the order structure. Get maker amount and get taker amount functions. We have built-in functions on the limit order protocol. This is just proportional formula to calculate maker amount given taker amount and in other turn. You can build your own functions using your contract. Then our call get maker amount function will execute this method on your contract, and your custom price discovery algorithm will be executed too. And if you want to call some functions on your contract, you need to proxy your calls through the arbitrary static call on the 1-inch limit order protocol. You just need to place in parameters target address of your contract and also the bytes of the data, which contains function signature and other parameters. And this function will allow you to execute some function on your own contract. This works for predicate and also for get maker and get taker amount. And if you want to build something like strategy, the contract for your strategy that will interact with 1-inch limit order protocol, then you need to implement is valid signature function. And you don't, it's not necessary to place a real signature in this function. You just need to place the data that you want to check to confirm that no one want to steal funds from your account, and just validate this properties inside this function. For example, here you can see the validation of the order that stores inside the signature parameter. And if the order is correct and no one want to steal funds from you, then you can just return the selector of this function. That means that the validation pass through your contract. And last thing, it's iteration. You can perform any action before transfer from maker account, transfer funds from maker account. And in case if the iteration property in your order structure has more than 0 bytes, then we um, make the call to your contract, which should be the maker of the order, and we call notify fill order, which contain maker asset, taker asset, making amount, taking amount, and also any abstract data that you pass to iteration property. And using this functionality, you can maybe build your own order book, or maybe price algorithm, or maybe just for tracking some orders. It's also very good for the liquidations on compound or AIF protocol. You can build whatever you want with this function. I
Hey,
think
hey, Kirill,
yes.
just to interject, a few chats we're getting. If you could zoom in a little bit, yeah, that'd be great.
Zoom.
Yeah, because the text might not be visible to them when they're looking at it.
Mhm.
Yeah, thank you.
Okay.
You can carry on, Kirill.
It was
Looks
the
good.
last slide, and
That's
yeah,
absolutely all right.
yeah,
That's
and
absolutely all right, Kirill.
here using
Carry
this,
on.
yeah, here using these QR codes, you can look at the contract code, look at the JavaScript utils for the iterating with the limit order protocol, and yeah, you can check the documentation here. You can find Ethereum mainnet address, all deployed addresses, how to build your custom orders, how to cancel limit order, how to fill, how to build the custom predicate, and other interesting things. Thank you. I think I told all things about the limit order protocol. If you have any questions, I'm ready to answer.
Hi, Carol. We have some questions in the chat. So one of the questions is, does 1inch collaborate with other strong fundamental crypto projects, or is it solely like based on its own? Like, do you collaborate with any unmentioned collaborations with crypto projects in the space?
Uh, yes, for sure.
For
We
sure, right?
have we have a lot of integrated protocols to the aggregation protocol, and we communicate with each team. Sure.
Another question, same person, Danish, is asking, the limits that we set, are they viewable to other users, or is it just between the owner and 1inch?
You can use the Swagger API to get all placed off-chain limit orders. The link you can find in the documentations. I can send the link to the limit
Right.
order tools. Yes, and you can
Sure.
just call the methods on API, and you will get all placed limit orders.
Okay, sure. I'm sure we can get the link to the documentation of the chat or something like that. Um, Another question is, which programming language is used by a 1-inch project on the back end side, and does it involve any automation like machine learning or artificial intelligence?
Uh, I think that AI is cannot provide very close rates. For example, if you want to exchange one ETH to DAI, you should receive the exact amount of the DAI that you see, and AI allows you to get uh, not close rate, and we don't use it. Yeah, about languages, that we use almost all languages
Yeah,
for the
fair enough.
development on the blockchain. Yeah.
Sure. We have a question from your namesake. There's a Kirill Mandarin in the chat who asks, could you tell more about how automated market making strategies for stable coins can be implemented using 1-inch's limit order protocol?
Okay. For example, the easiest way how to do that is to set the fixed rate. For example, you have the wallet or the smart contract that hold some amount of DAI and some amount of USDC, and you can include the fixed rate for exchange DAI to USDC and get some fee from these rates. The more interesting thing is to build something like curve with dynamic fees, and yeah, you can build whatever you want, but the easiest way is just fixed rate, get maker amount and get taker amount function that will return the rate, including on top fees.
Right.
For example, if you want to swap 1,000 DAI, you'll get 997 USDC, for example, something like this.
Um, we have a question from Anupam. How come centralized exchanges are able to give better interest rates than decentralized exchanges for lending crypto, especially USDT?
Um, I think centralized exchanges is not fully use um, DEX in- incentivized protocols, and they build something like storage in database. I don't know actually how they do that, but on the decentralized place, we have more trusted protocols that can bring the liquidity inside this protocol and incentivize the liquidity providers, uh, something like this. I can say for sure how centralized exchanges can improve these rates. I think these rates correlate with the decentralized one. Maybe some centralized exchanges have uh, maybe collateral on some protocol inside the decentralized space, and they just distribute this reward amount among their centralized stakers, maybe something like this.
I have more of like a general question from my end. Like, do you see the crypto industry moving towards like more decentralized products, or do you think it's going to be a synergy between centralized and decentralized products kind of working together?
Uh, I think right now it's a synergy. The centralized exchanges helps maybe decentralized projects, and other way this is the two sources, and each source accumulate the users of another source. For example, users from the centralized world, they the centralized exchanges can attract users from the centralized world, and so the centralized world can attract users from the centralized.
Right. I mean, do you think we'll start seeing like decentralized on-ramps for fiat currencies and things like that? Like, do you think they'll become more prominent, or like, because right now it's probably the one thing that's like properly differentiating why to use a centralized versus decentralized platform.
I talking about fiat or ramp, or why users should use decentralized. Which
No, I
one?
mean like, do you think we'll start seeing decentralized on-ramps like in the future, like more prominently?
On ramps means that.
Meaning for like fiat to crypto conversions right now
Okay.
in a decentralized.
I think in the centralized world, we can see something like USDC, maybe USDT as the uh, dollar stable coin, and this is the bridge to the decentralized finance, something like this. But we can't provide real world assets to the decentralized without external providers and oracles.
Yeah, fair enough. Um, I think that's all of the questions from the audience as well. So if you have any closing thoughts, we could just start off with that and then wrap up. Um, Kirill.
Um, Thank you for the watching this quick tutorial.
Is there anywhere like the viewers can follow you, like on Twitter, or maybe
I
they can reach out to you somewhere? Like,
I
no, you
don't.
don't have Twitter. Fair enough. Fair enough.
Yeah. Oh no. Yeah, I was trying to tag Kirill in a post on Twitter. I couldn't find him anywhere. He's not on Twitter. That's for certain.
It's off the grid.
But anyway, thank you so much, Kirill, for coming in, for taking the session. Thank you, Manu. Thank you for the chat, for the people watching who are asking questions.
Thanks so
Again,
much,
Kirill,
Kirill.
thank you so much for coming
Thank
in.
you.
It was really informative. Next session begins at 5:30. It's by Dan Adelbeck, who's the CEO of Exedio, and he's speaking on Web3 and the future of the internet. So tune in at 5:30. Till then, please go ahead. You can download the rest of the agenda from the reception. You can go to networking and chat with any of the people who are here. If you're attending the hackathon, so, you might as well find team members here while talking to them. We'll see you at 5:30. See you then. Thank you.
Thank you. Bye bye.